Hi everybody, welcome back. I was going to do a little video on a phonograph that I have some work to do on, and I was going to do a little bit of an opening on kind of the new, it seems like a renewed interest in vinyl records and so forth. And I was really excited about doing this. I have a nice Techniques turntable that I wanted to finish up some work on, and I thought I'd do a little video. But I decided to put that little project aside because of the number of emails I've been getting lately. Now every month I get 2 or 3 or more emails asking me how you can substitute transistors or how to test or replace transistors. A lot of you are getting into this hobby. It's a new thing to you, and I think it's wonderful. I think it's great. And a lot of the interest seems to be in audio amplifiers, either integrated amplifiers or receivers or so forth. And the problem is a lot of times these old transistor amplifiers that are now getting to be 30, 40 plus years old are starting to fail. The transistors are failing in them, and you can no longer find the transistors that originally came with the unit. So the question becomes, how do I replace the transistor, or what substitute should I use? Well, I'll give you a little story. You like my stories, don't you? If you want to learn how to bake a chocolate cake, you can Google it, right? We are all Google scholars these days, aren't we? We can Google it, and you can look up how to make a chocolate cake. You can follow the instructions you read, and you can bake a chocolate cake. However, if you want to learn how to bake your grandmother's favorite chocolate cake, the only way to learn it is to sit by her side, watch how she does it, and then repeat the same process yourself time and time again until you get it right. 2 totally different things, isn't it? Transistor replacement is very similar. So what I'm going to tell you up front in this video is, if you're just looking for a quick video to show you how to replace one transistor with another, hit the dislike, shut the camera off. This is not going to be a video for you, because I do not know how to show you that in that manner. But what I will do is share some of the information that I have learned over the years that I use to help me choose the correct substitution transistors when I'm repairing these amplifiers. Now there's 2 terms I'm going to use, and I'm going to apologize up front in case I get confused, because you know me, this stuff's unscripted. But I classify transistors in 2 groups. So, and I'm going to use these 2 terms, and we can all argue over the real meaning of it or not, but I'm going to tell you what I mean by these 2 terms. There's a replacement transistor and a substitution transistor, those 2 terms. A replacement is what I consider a transistor that is the same transistor, only manufactured by another manufacturer or something. A substitute transistor is a transistor that may be a little bit different than the original one you're trying to replace, but it will work the same way in the circuit that you're using it. Those are 2 very important differences: a replacement transistor versus a substitute transistor. We get a lot of questions about how reliable some of these substitute companies, such as NTE, ECG, or the old RCA-SK even, how reliable they are as replacements. And a lot of people will tell you a lot of horror stories online about it, but the fact remains, the transistors are usually good quality, the NTE ones. And ECG and SKs are very high quality, but they don't make them anymore. Those are old now. NTE transistors, however, are usually, and I say usually, pretty good quality. The problem is sometimes they will use a transistor as a substitute, not a replacement. And what that means is there will be sometimes, you may have instances where you will replace a original equipment transistor with an NTE substitute, and it may not work perfectly. It's rare, but it does happen. However, in most cases, if the manual says that it's a suitable substitute, then it probably is. So that's the one thing you need to know. It can work, it usually works, but once in a while you find a situation where it doesn't work. Hope that clears that up. So now let's go down to the bench and look at a whole bunch of different things, and we'll kind of try to drill down how we can find suitable replacement and or substitute transistors. Boy, I hope I have this whole thing in shot. I think I do. So we have a bunch of things here on the bench, and we're going to go over them. And the first thing we're going to talk about is some of these substitution or replacement manuals. The next thing we're going to talk about is how to test a transistor just in a basic manner. We're not going to get into curve tracers or complicated things like that today. We're just going to look at some basic things. And then third of all, we're going to try to look at the different specifications of transistors and how we can choose a suitable replacement or substitute for that transistor. And really what it's going to come down to, what you're going to find out, is two things. The specification of the original transistor and the one you're going to substitute it or replace it with, and the actual circuit that the transistor will be used in. Sometimes a transistor that doesn't very closely match the original may work just as well or better in that circuit simply because of the circuit's design itself. So hopefully we'll be able to clear some of that up in this video. So let's start with these books. First and foremost, let's look at this book, and we'll talk a little more about some other things. Just to give some age to this is one of the parts houses that used to be around where I live, at least within a half an hour or so of where I used to originally live. And it has long since gone out of business. But when you used to go to the parts house, you used to be able to get these books. I don't know if they still make them or not. I know you can find them online, old ones, like this one. I believe that NTE still does make them. And these are a really good resource. And this could be a starting point when you're trying to replace a transistor. But what it will do, it will show you how to translate another transistor to a suitable NTE substitute or replacement. What it cannot do is the other way around. In other words, you can't look up an NTE transistor and know what transistor that it goes to. You can go one way but not the other. If we look at these transistor manuals, and NTE does more than just transistors, they make all kinds of replacement components. But if we go to the transistor section at the beginning, you can look up the numbers, and the way these books work is in the back of the book is the cross-reference, and in the front of the book is the description of the NTE components. So for instance, I have a 2N3055 transistor. See it? And I can go into this NTE manual and I can look up the 2N, and I can go through, and they're all listed. And there's a 2N3055. See it? So 2N3055. And there's a whole bunch of them, right? And they all mostly cross over to either an NTE 130 or an NTE 181. So this is just a straight 2N3055. It's a G model. 2N3055. And G's not even listed here. But what I will tell you is it crosses over to a 130. There's an H, but 130. Now, after you know what transistor it crosses to, you go to the front of the book. So you flip through the pages until you find the same case, which this is a TO3 type case. And you go down here until you see NTE 130. And you can see the NTE 130 and the 219 are complements. So this is the NPN version, this is the PNP version. And we can see a 130 is an NPN. It's a power amp, general purpose. Collector to base is 100 volts. And collector to emitter is a maximum of 70 volts. The collector current is a maximum of 15 amps, and the maximum that the wattage that this transistor can dissipate is 115 watts. Now you have to remember, this 15 amps can't necessarily be at 100 volts, or of course you would be exceeding that 115 watts by a whole lot. So the higher the current, the lower the voltage can be, and vice versa, because the two combined, because watts equals volts times amps, cannot exceed 115 watts of heat dissipation. It also shows you the forward current gain, which on this one is 20 minimum, and it'll show you the transition frequency on this is relatively low, isn't it? It's only about a 2.5 megahertz transistor. So this is not a really good RF transistor, it's really an audio transistor. And you can see they call it a power amplifier. And that's how you look it up in the book. And these books are good because you can look up the different transistors based on their case type, and you can find ones that can kind of match the voltages and wattages and so forth that you need, and it makes it very easy. Now, in addition to this, there is an app called NTE Quick Cross, and you can load this onto your phone from the Play Store, and it's the same thing. 2N3055. And you can see there, it shows you the same thing, and we can hit that data sheet, and it takes you right to it, and this will give you the actual full data sheet for that transistor. A lot more information than just that little book shows you. So this is another way, if you have, if you have the electronic means to do this, you can look this transistor up. So that's one way to find a replacement or substitute transistor using the NTE manual. Sometimes I'll use this to get a rough idea of what kind of a semiconductor I'm looking at. Because sometimes the transistors, there are no data sheets available or online, or they're hard to find, or they're limited information, but you can find a crossover in the NTE manual, and you can use that information to at least give you a rough idea of what NTE is using as a substitute. Now the next thing we have are called transistor substitution manuals. And there's quite a few types. So for instance, this one was made by Howard Sam's publication, as in Sam's Photo Facts. They made a whole bunch of different things. Actually, this book was made by them as well. This is a specs manual, and this is nice because this one has a lot of the older transistors, the really old ones that are very, very hard to find information on. And it's nice because you can look them up. They're just listed. They don't show you the case type or anything like that. All they're showing you is they give you an idea of who makes them. For instance, Motorola, Delco, and so forth. They go on. Different manufacturers. It tells you if it's PNP or NPN. See, the P means PNP. G and S means either a germanium or a silicon transistor. Tells you the lead identification, and you can look that up. There'll be a chart that shows you the lead identifications in the back of the book to tell you the pinout. It tells you what kind of case it's in, a TO3. It shows you the collector base, the collector emitter, and the emitter base voltage maximums. It shows you the maximum current for the transistor, for collector current, and the maximum power dissipation. It also shows you the maximum frequency or temperature that it can work, degrees Celsius. It shows you the frequency response, and it shows you your leakage voltage, because this is a germanium transistor, so this is a low frequency transistor, and it's a you can see it does have some leakage, 3 MA of collector base leakage, and you'll find that germanium transistors, that's a characteristic. We'll get more into that another time. It'll also show you the forward current gain, which is 20 in this case, and that gain is 20 when the collector current is 10 amps. So there's a lot of information about a whole bunch of different transistors. If you can get your hands on one of these old books online, great thing to have. Now, this won't tell you how to substitute a transistor, but it'll tell you a lot about an original transistor from your old audio gear. Another good book is the actual substitution book. And remember, they're calling it a substitution. That means that it should work, but it won't always work perfectly. And sometimes they'll put little notes to tell you that. And again, you can look up a transistor like 2N791 and look at the big list of ones that they have. Now what you're going to find though, for instance, a 2N791, they're saying you can use an ECG or NTE 123. But there's a whole bunch of substitutes that you can use that will work. You'll notice though that sometimes they put a little asterisk mark next to it. And if you go to the beginning of the book, see those little symbols, they will actually tell you general purpose replacement transistors marked with an asterisk as recommended by the manufacturer of the replacement. So that means, and they're using the word replacement in opposite how I'm using it. They mean substitution. So what they're saying is if it has an asterisk, it's a substitution, it's not a perfect replacement, and it should work in most cases, if that makes sense. Okay, so and you can see how, again, now that's a good replacement book or a good substitution book. This one is a modern book, and I think it's still being published, and it deals with Japanese transistor data and substitution. And again, it shows you different transistors, and these are going to be the Japanese ones like the 2SA, 2SB, 2SC, unlike the 2Ns and so forth that you see in the other book. And they show you the replacements, or the substitutes, substitutes that can be used for this. And again, it will have little notes sometimes where you can see the polarity can be different, where the pins might be swapped around or something on the substitute, but other than that, the transistor will work. So this is another very good book, especially when you're working on the old Japanese receivers like the Sansuis and the Pioneers, the Kenwoods, the Marantz, all those kinds. Very good to use this. Now these books are all good, and you might say, well, all I need to do is run out and get these books and I can shut the video off now, huh? If only it were that easy. The problem is that all of these books were written at a time when the transistors that they are using to substitute with have become obsolete themselves. And the more common ones that are in production today have different part numbers. This is a very good example. Two of the most common small signal transistors I use in vintage audio amplifiers are these two complementary pairs. For the NPN, it's a KSA, and that's Korean Semiconductor, I believe that's what that stands for. KSC, I'm sorry, KSC 1845, which is a good low noise audio transistor for small signal, and it's NPN, and its partner is the PNP version KSA 992. You will find that nothing that begins with the letter K, the KSC or the KSA, will show up in any of these vintage books, nor will anything with KSC or KSA show up in this, nor will KSC or KSA show up in this. And believe it or not, the most prolific manufacturer of substitute transistors for vintage audio equipment is the Korean Semiconductor company, the KS version. And there are multiple manufacturers out there like ON Semiconductor and so forth that are making these, but they all start with the letter K, and none of these books will help you. And that's why when people ask, well, how, give me an easy list of what translates to what, I can't give that to you. What I can tell you is if I've used it in the past and it worked, or if I've done the research and it worked, I can share that with you. If you go on to the Audio Karma or DIY Audio or many of those forums that are online, a lot of people like myself have gone on there and have shared that. What I've found is in many cases, the things you find on those audio forums are pretty reliable, the information you get. What I've also found is sometimes it's not reliable. They tried something, it may have worked for them, you try it in your instance and it doesn't work. So once again, don't always trust everything you see on the internet. And yeah, you're watching this on the internet, so I'm a bit of a hypocrite, ain't I? Well, no, I'm not, because I'm telling you not even to trust me. Do your homework. Look it up and go through and do the research so that you know that you're using the correct component. And again, I'll go over the process, how I do it. And hopefully that'll help you develop your own process for how you substitute or replace transistors. Let's go through a typical scenario where you can easily get lost or not be able to find something. Here's a transistor, and we don't know what it is, do we? It's just a transistor. We know that it's a type, what is this, a TO, is that a 202, TO202 case or something similar? We don't know. But what we do know is that it has some markings on it. And one of the markings that we see, let's turn a light on here and see if it helps us any. I don't know, can you see it? It says A, the big letters at the bottom say A004B. Now there's these smaller numbers on the top that are manufacturing numbers, 818073, and there's a little insignia at the top. It looks like a funny looking letter T, but we're not sure. Now, usually the larger letters that are more prominent are going to be the actual part number of the transistor. So it's an A004B. Now I can't see very well through the camera, but I think I'm focused in. If we look again at the characteristics, the first thing we want to know is who the manufacturer is. If we can find out who manufactured this, what they do quite often on transistors is they take off the first couple of numbers or first couple of signifiers. So for instance, this could be a 2SA004B. It can be a KSA004B. It can be a TTA004B. There's lots of numbers. What do they mean? Well, a lot of them have to do with the originating manufacturer of that component. This T, believe it or not, is a signifier of Toshiba Electronics. So this is a Toshiba transistor. And most Toshiba transistors begin with the signifier of TT. So how do I know that? I know it because I just know it. That's a thing from experience. And once again, these are things that you can't always look up on the internet unless you have a little bit of previous information. So if I'm right, we should be able to type that in up here, and we should be able to see what it comes up as, right? So let's try it. TTA004B, and let's look that up. And you can see the first thing that pops up now is a transistor from Toshiba, and it's even showing you from Mouser Electronics. Now, that's the trick. You have to start to be able to recognize these manufacturing symbols. So for instance, this here, this 2N3055, I don't know if we can see it without me moving things. See the little ON in the side the circle? That's ON semiconductor. I'm having a hard time here without moving the camera around. ON Semiconductor is a big company, and you can go to their website and look things up the same way. But you can see Toshiba uses TT, and they don't always put it on the actual component when they print it. They assume that because you see the Toshiba insignia, you know what it is. Now, if you do find it, like we did, and you go on Mouser's website, they always have a data sheet there, and you can see it's a PDF. So if we click on that, it will open it up, and now you have a complete data sheet of what this transistor is, and we find out that it is a PNP type transistor, and it's an epitaxial type transistor, which modern ones are mostly use that manufacturing method. That's the type of transistor it is. It's a silicon transistor. That's the main thing you need to know. And you'll find that anything that, for the most part, that has the letter A after the insignia, it's going to be PNP, and anything that has C after it will be an NPN, or a B after it will be an NPN. So a TTB, or I'm sorry, a TTC004B, let's try that. And there it is. And you can see that the TTC is the same transistor, except it's an NPN. See right there? And if we click on this, there's the data sheet. And once again, it's an NPN transistor, and the TTA is a PNP transistor. And you have the whole data sheet, and it tells you all the characteristics of the transistor, including the curves. A lot of these data sheets give you all the information. Some of them just give you the basics. And again, it depends on the transistor. Now that was a relatively difficult one because it's those Japanese transistors, they always cut off. So like the KSA and the KSC, they do the same thing. If you look here, let me bring this down. If you look, come on, focus. This is a KSC 1845. But if you notice, it just says C 1845. And the same things will happen if you just type the letter C 1845 in a search engine. Sometimes you'll find it, sometimes you'll find nothing like it. But if you understand that it's a KSC, then you can look it up. You can also type in 2SC 1845. What will happen if we do that? 2SC 1845. You can see it's an actual transistor, isn't it? And let's see if we can find a data sheet for it. These, let's see here. 2SC 1845, and there it is. the 2SC and the KSC are the same. So if we look at some of the basic things, collector base and collector emitter is 120 volt maximum. On this one, collector emitter is 120 volts, and I'm sure collector base will be the same. Let's see. It shows that your HFE, or your forward current gain, is about, it can be 600 on average. When you look at these ones, the forward current gain is different depending on the classification. So that would be an F classification, would be a 600. An E classification would be between 400 and 800. So you could see there are different versions of the KSC, but there's only one version of the 2SC. I'm sorry, there's not. I needed to scroll down. So you could see the same thing here. So the KSC and the 2SC are almost identical replacements for one another. When we deal with the older, like the 2N transistors, anything that starts with the letters or the signifier 2N, those are much easier because they always start out with 2N. They don't leave the 2 off of it or anything like that. It says 2N. So the older transistors, like you'll find in the older Macintosh, well, I shouldn't say that. Macintosh wipes the letters off and puts their numbers on as well. That's another thing you'll find out. Manufacturers, such as Macintosh, that's a good example, will take a standard transistor and they, like for instance, a 2N2222 or a 2N3904, they'll rub the letters off, or they will contact the manufacturer and have them stencil their own specific part number on it. You have to do a lot of research, talk to a lot of people, or do a lot of testing. Now that I've shown you some of the pitfalls, I want to now kind of cheer you back up. Not all is lost, and it's not impossible to do this. Here's a schematic of an older Pioneer piece of audio gear. This is the Spec 1 preamp, and this is a random circuit board, or a random circuit out of the Spec 1, and it has, as you can see, a bunch of different transistors. And you can see they're all Japanese type transistors. They start with the 2SA and 2SC type signifiers, right? And this is what you're going to see normally. This is why it's important to have a service manual or a schematic when you're working on these, if you can. Now, there's always, you can use your experience and so forth to find things out if you don't have a schematic, but this makes it exponentially more easy. And if you're new to the hobby and you're just getting into substituting or replacing transistors, it really helps if you have a piece of gear that you're working on that has a good schematic. So for instance, let's look one of these up, 2SA726. And you can see the X2 means there's 2 of them here. So you can see these are in a pair. And this is called a differential pair. And these transistors are going to have to be matched, but we're not going to talk about matching in this video. We're talking about right now substituting or replacing. So let's say that we need to replace one of these transistors around here. So here's another 2SA. This one down here is a 2SA912. And we can see this one down here is a most likely going to be a 2SC 1775. So let's say this one needs replaced. It's a 2SC 1775A. Now I'm going to assume you do not have any of those substitution manuals for the Japanese transistors or so forth. So we're going to try to just use what method most of you are going to use, and that is the internet. It's the easiest way in today, with modern technology. So let's go up to the internet and let's go on Google and let's do 2SC 1775. So you can see as soon as I type that in, There's all kinds of things. There's equivalent, replacement, substitute, all kinds of different things, but we're just going to look up the number. So we're going to do search. And I always, if you want to get through all this garbage, because there's a lot of these data sheet websites that try to sell you data sheets, or worse yet, try to spam you with advertisements and things. So what I will do is I will do 2SC 1775 PDF. Most data sheets are online in PDF form. So if we look here, the first thing on here, it looks as if it's a PDF. See, it says that it is. We're going to click that. And it says that it's a Hitachi silicon NPN epitaxial transistor. And it's a 1775A is what ours is. So we're going to click on that. And we can see we can get it directly from Hitachi Semiconductor. So we're going to type that, and there it is. Look at that. And we can actually download it to our computer. And I like to, instead of looking at it on the internet, I like to look at it on PDF. So let me open, and there it is. And if we scroll down, you can see the first thing it shows us is the pinout. That's very important, because sometimes our replacements are going to be, or our substitutes may have those pins swapped around. It might be a perfectly suitable substitute, but you may have to swap the pins around. Sometimes it's base collector emitter instead of emitter collector base, which means you would have to face the transistor the opposite direction when you put it into the circuit board. So that's good information to know. It shows us that the difference between the 1775 and the 1775A is the maximum voltage. You can see they both have the same wattage, right? They can only dissipate 300 milliwatts. But this one has a higher voltage rating than this one. So you want to make sure whatever we replace it with is going to be suitable for 120 volt or higher. So if we look at the circuit here, here's the transistor. I'm sorry, come on, focus. There's negative 47.7 volts, and there's a negative 48 volt supply going into it. It says there's negative 1 volts here. We don't know when it's active, what that swings to on the other side, but probably the 1775 would work, but we want to use the same thing, right? Now, a couple other things. If we scroll down, the transition frequency on this is 200 megahertz. So this is a very high frequency transistor. This is an important thing that a lot of people overlook. Sometimes it has to be that high of a frequency for the transistor to be able to perform properly, especially in an RF circuit. However, in some older audio gear, if you take a transistor that has a very low transition frequency, the original one, let's say, the old transistor, and you replace it with one of these guys that has a really screaming high transition frequency, you'll find that sometimes these newer transistors like this with high frequency will oscillate. They'll go into oscillation. And the original transistor did not. And that's why. It's because the circuit doesn't have any compensation for that oscillation, because it can't oscillate because those transistors won't operate at high frequency. You put one in there that does, all of a sudden you just introduced a problem. So this is something you want to look at. The other thing you want to look at is not only the dissipation, see this one's 300 milliwatts, but you want to look at your collector to base, collector to emitter, and emitter to base voltages, and you want to match them up so that they're similar to this. You normally don't want to go lower than the numbers. It is okay sometimes to go a little bit higher. The other thing you want to look at is VBE, and those are always going to be somewhere in that 0.7 volt range. And they're showing you that a lot of times they'll show you what the VBE is versus temperature. That can have an effect on a circuit, especially in a bias circuit. We want to look at the HFE, and again, I think there's a little asterisk there. They're going to show you once again that these transistors have different ranges. You could see this one will go anywhere from 400 to a forward current gain of 1200, and I have a feeling there are 2 or 3 or 4 different gain ranges you can pick from. So you have to make sure that you get the right one. They don't specify it on this one in the schematic, so you can either look at the component itself to see if there's any other markers, or just disregard it because it probably doesn't matter because of the way the transistor is working. Sometimes when it's just being used in like a linear power supply or something like that, the gain isn't a big deal. Also, when it's being used in an output section on an amplifier, the gain isn't as big of a deal as the VBE is, or so forth. So those are the kinds of characteristics we want to look at. Now, looking at this, I'm going to take a guess. This is, once again, a NPN transistor. Let's take a look at our KSC 1845. All right, so I'm going to type that in, KSC 1845, and you can see there it is, and there's the data sheet. And if we look again, this one goes emitter collector base. And if I go over to the other one, emitter collector base, so we have a good match there, right? $120, $120, 5 volts, 50 mA, 10 mA. So our collector current is 50 mA. Let's look at those numbers. Collector current, 50 mA, 120 volts for VCB, 120 volts for VCE, 5 volts for VEB, 300 milliwatt dissipation. Let's scroll down on this one and see this one's a 500 watt dissipation, meaning a 500 milliwatt dissipation. So this transistor actually has a little bit better specification. And if we look at the gain ranges, it also goes from about 200 up to 1200. So depending on the signifier at the end of that transistor's part number, we can match it up to a similar one on the original. So I would say this would be a very good replacement, not just a substitute, but a replacement for the 2SC 1775. You're going to ask, how did I know that? Well, that's where it's good to have a little arsenal of transistors that you keep in stock. You're going to find out that there are a few repeat transistors that are good substitutes or even good replacements for a lot of the original Japanese transistors in the amplifiers that are out there. So let's look at a couple of those. Now that you have kind of at least a rough idea how to look things up and how to search for them and some of the pitfalls you may run into, here's a little list I wrote down of kind of your arsenal for at least the small transistors. Now we can do the same thing for the larger power transistors or for the TO220 type driver transistors and so forth. But most of the ones that you are going to see that are going to fail are going to be the small ones. They're the ones that get noisy and so forth, and they're also some of the ones that are the harder ones to substitute or to replace. Don't go out and buy all of these. By all means, if you're not somebody who does this for a hobby or does a lot of this, you don't need all this stuff. But what I will recommend is go online, and this is a good exercise for all of you. Go online and do the search for each one of these. And what you'll find is what these are I'm giving you is the PNP and NPN complementary pair. What that means is these two were designed to work together. They have similar characteristics. The only difference is their polarity. This one is a PNP, this one's an NPN. This one's an NPN, this one's a PNP. This one is a NPN, this one's a PNP. NPN, PNP, so forth. But look up these data sheets, download them to your computer, and save them. Because if you have this set of data sheets right now, these ones that I've just shown you, then, and I can erase this because I have it written again down here, see it? If you look at these and you download these data sheets, what you're going to find is a large number of the transistors that you're going to see in the little amplifiers you're going to work on and on the receivers you're going to work on, especially the Japanese ones and so forth that are so popular. You'll find out that when you look up the data sheet for those old transistors, you'll be able to match them, or at least find similar ones to at least one of these somewhere. Each one of these are all similar, but they all have little differences in the transition frequency, in the maximum voltage, in the maximum dissipation. Some of them are low noise transistors, some of them are not. Some of them work very well in the higher frequency ranges, some of them don't. And you can use this as your baseline to kind of find something that matches up with it. Let's do that as a starter, and then you can build off of that. How's that? All right, there you go. Take a screenshot of this. Take a look at it. Write those down. These ones here at the bottom can sometimes work in place, even though they're a different package. They come in this package. If you see those little TO5 transistors, those little silver metal cans, and a lot of them will cross over to an NTE 128 or a 129 for the NPN and the PNP. These are 1 watt small signal transistors. They're a little bit bigger. You usually see them in driver circuits or pre-driver circuits in an amplifier. I've used these and they work very well in place of that. These are a much higher power dissipation. They're a little bit heftier, and they can handle everything that these can. So, because you're going to find those TO5 transistors, and they use these in things like the Macintosh and so forth. They're not called NTE, though. They have different numbers. These are just, like I said, these are NTE equivalents. But once again, these are a good substitute, so they're good to keep in stock. Anyway, here they are. Look it up, download your data sheets, and that's going to give you a really good start for the substitutes. And as you start going through these and looking up the data sheets, for instance, like we just did for that 2SC 1775, you're going to find that there's a transistor that's going to come very close to matching it. Now, one other thing I'm going to remind you of, I said this earlier in the video, always, always, always check the pinout of the transistor that you're replacing and the new transistor you're replacing it with. It's very important because quite often the pins get swapped around, like I said. If you go back, the last video I did on the Pioneer SA7500, we were replacing those 2SA 725s, I think they were, or 2SA 726s, whatever they were. We were replacing them with these newer KSA 992s, and they were a good suitable replacement, or substitute I should say, but the pins were opposite, so you had to flip the transistor around. So if it was plugged in this way originally, the new transistor is plugged in this way. If you don't do that, you're going to let the smoke out pretty quickly, and we don't like letting the smoke out of things. So always check your pinout. I'm going to end this part right here, and we'll come back with another part of this series dealing with testing transistors and so forth. But I think this is enough for one video. And just so you understand, the same techniques we used for looking up and crossing over the small signal transistors, we can also use for these larger transistors. And there's quite a difference in a lot of these as far as the case types mainly. But you'll find that these power transistors are a bit more forgiving with the specs. The main thing you have to worry about with output power transistors, in most cases, but not all of them, is the dissipation, how many watts, and the voltages for your collector emitter, collector base, and so forth. As long as you're within the tolerance of that, a lot of times the way these things work, they're not really used to produce gain in the circuit, but rather to handle the excessive current that the load of the speaker will place onto the amplifier. So these really don't do a lot of things that you have to worry about, stuff like gain and so forth. And by having the emitter resistors on there, even if they're not perfectly matched, it doesn't make much of a difference. So again, these are a lot easier to find substitutes, even if you can't find a perfect replacement. Anyway, let's leave it at that. And I know that there's probably a whole bunch of things I didn't cover. There's things that probably people want to correct me on, whatever the case may be. But that's what this channel is for. Put the comments in there and let's help each other out. Again, I thank you all. I've received quite a few emails from all of you lately. I've received some donations and things that I'm very appreciative of. I don't like mentioning names and things without people's permission, but you all know who you are. I'm very thankful and I really appreciate all that you're doing. And just know that anything you do like that, I'll make sure it stays on the bench and we use it for making more videos to hopefully entertain you and so we can enjoy some time at the bench in the future. Anyway, I wish you all peace, joy, happiness, and good health. And until the next part comes out, stay well, and we'll see you again soon. Bye-bye.